As we know that matter is made up of atom, and atoms are made up of three subatomic particles: electron, proton and neutron. Now in this topic we will be taking up the discoveries of those subatomic particles, that how they were discovered. So you will be glad to know that the first discovery was made by the J.J. Thomson. See, look, he is the one volunteer who made a great contribution, whether it failed or succeed, but he was the one who made the first contribution in many fields. Like he was the first to explain the structure of atom, no matter that it was discarded, but still he made the effort to do that. And similarly, he is the one who discovered the electron, and he was successful in doing that, and today we know the electron just because of J.J. Thomson. So how he discovered the electron, we are taking up this, that what apparatus he used, what were the conditions he used to explain the discovery of electron, because to make such a discovery was not an easy task. So just look at the apparatus he used. He actually took the Crookes tube. He actually took, I repeat, the William Crookes tube. Now what is it exactly? It is just a tube made up of glass, as you can see, a thick glass, approximately 0.5 meter long in length. It has got, you can see these plates, right? It has got two metal plates present at each corner. These were connected by means of wire to the terminals of battery. The battery which he used was of high voltage, approximately 10,000 volts. And to this tube there was a small tube attached which acts as a vacuum pump, which is used to reduce the pressure inside the tube. And you know what he took inside the tube was a gas. He took actually a gas, yeah, it is mentioned here. He took air at very low pressure. So when he started the experiment, he actually took air at a normal room temperature. Now we will get to see that what happened in the experiment and what observation he get to see when he was performing the experiment. So before we proceed, you should know that the gases are conducting was already known. It was proved by Faraday that gases are conducting only under two conditions. One condition being the high voltage and the other condition being the low pressure. So the J.J. Thomson knew the fact. So while performing the experiment, he kept these two conditions in mind, that if we want the gas to be conducting, he has to take the battery of high voltage. So he took the 10,000 volt battery, and firstly he took the gas at normal room temperature. Sorry, I am using the word temperature, it is pressure, normal room pressure. So atmospheric pressure. So what happened, what he get to see? So first when he applied the high voltage, that is 10,000 volt battery volts, and took the gas at atmospheric pressure. As you all know, the atmospheric pressure is 1 atmosphere. So what happened? He get to see no change. There was no change. Nothing happened in the tube. So that shows that he concluded that the gas was non-conducting under these conditions, that is high voltage but gas at 1 atmospheric pressure. So that means when they were connected to the battery there was no change observed. So that means gases remain non-conducting. Then what he did, the idea came to his mind, then what he did, the battery was still of 10,000 volts, because 10,000 volts is a high voltage. So then what he did, he reduced the pressure of a gas to approximately 10 raised to power minus 2 atmosphere. Then what he did, he observed certain kind of changes in the tube. And you know what those changes were? What changes were? The tube started glowing. The tube started glowing. So this change indicate that the gas became conducting. So under this condition, the 10,000 volt battery and a reduced pressure of 10 raised to power minus 2 atmosphere, the gases became conducting. So next what he did, he further reduced the pressure because he wanted to see that what actually happened if he reduced the pressure more. So what he reduced the pressure from 10 raised to power minus 2 atmosphere to 10 raised to power minus 4 atmosphere. Then what did he see? You know, the glow actually vanished. Earlier the glow was that the whole tube was glowing with the greenish light, but when he reduced the pressure to 10 raised to power minus 4 atmosphere pressure, the glow vanished. But still he was able to see a faint glow at the side, at this side, the anode side. He was able to see that faint glow, but actually he was not confirmed that whether the glow was there or not. So to confirm that, you know what he did? He was very sharp minded. So what he did, he made the anode perforated. Perforated means the holes in anode, and he just covered the back side of anode with the fluorescent material, that is zinc sulfide screen. As you all know, the fluorescent screen is that when any beam of particles will strike it, it will produce a colorful pattern. So to confirm that whether there was some change or not, like that, so just for the confirmation, what he did, he made the anode perforated, and the tube which was behind the anode was covered by the fluorescent material screen, that is zinc sulfide screen. So what happened? So again, when the same condition was applied, that is the high voltage and the pressure reduced from 10 raised to power minus 2 to 10 raised to power minus 4 atmosphere, there was a glow, and a bright glow was seen in the zinc sulfide screen. So it was confirmed that under these conditions something was emitted from here, which was travelling towards anode side, because this was not happening on that side. It was when these conditions were applied, something was emitted from this side which was travelling here, crossing the anode, and when they strike the zinc sulfide screen, they were making it glow. So that means there was certain kind of beam of particles, or you can say a beam of rays, which were emitted, and that was because as they were emitted from cathode, so they were called as cathode rays. And we know as cathode is negatively charged particle, so that means that rays consist of beam of particles which are negatively charged. I repeat, as the cathode is negative, so that means the beam of particle also consists of negatively charged particles, and those particles, those cathode rays were called to be formed of negatively charged particle called as electron. So this is how the electron was discovered. I'll repeat again in a short span of time, just listen it carefully. Firstly, he applied high voltage and the gas at normal atmospheric pressure, nothing happened because the gas remained non-conducting under these conditions. Then he reduced the pressure from 10 raised to power 1 atmosphere to 10 raised to power minus 2. He observed the change. The tube started glowing with greenish light, which indicates that the gases became conducting now. Then what he did, he reduced the pressure from 10 raised to power minus 2 to 10 raised to power minus 4. What happened? The whole tube stopped glowing, but still he can observe the glow on the anode side. He confirmed that by making the anode perforated and by using the zinc sulfide screen. So it was proved that under this certain conditions, something was emitted from cathode, which was when striking with the glass tube or gas, it was making the gas particles as well as the tube glow as green. And the color of the tube, like it was green in this case, and if we'll take some other gas was taken, the color was different. So that means the color of the light which was emitted actually depend upon the gas which is taken. But it was confirmed that the rays were the same, that is, it was emitted from the negative charged terminal, that is electrode, cathode, and consist of negatively charged particle called as electron, and they were definitely travelling towards the anode. So this is how the electron was discovered. Now we'll take up the properties of these cathode rays. What were the properties of the cathode rays? So the first, to know that what kind of effect that cathode rays can produce, we know that cathode rays are formed of negatively charged particle electron. But now when I'll be explaining the properties, I'll be pronouncing the electron as cathode rays. So because we know cathode rays are made up of electron. So whether I take the property of the stream of electron, or I take up the properties of cathode rays, that is one and the same thing. So don't get confused. Okay, so we are now studying about the properties of those cathode rays which were emitted from cathode. So what happens? So to study it, what he did, he just placed an obstacle between the, you can say, any object between the path of the cathode rays. What happened? When cathode rays were emitted in certain conditions, when they travel, they just cast the shadow of that object after the object. So this shows that the cathode rays travel in straight line. Got it? I'll repeat again, just listen carefully. When the object was placed in the path of the cathode rays, it just cast the shadow of the object after the object, which shows that cathode rays were traveling in the straight line, because if they were not traveling in the straight line, the shadow won't have been cast on this side, right? The second property being, when the paddle was placed, see the paddle was placed with the help of axle and all. So what happens? When cathode rays were emitted, so it made the paddle move in this direction. See, if the cathode rays are emitted from here, this side, it made the paddle move in this side. This shows that the cathode rays can also produce mechanical effect. Means they can, as they can rotate the paddle, that means they can produce the mechanical effect. The third property being, I'll rub it so that you will not get confused with the things I have written on the board as we did in the electron discovery. Now you are all familiar with the conditions under which the cathode rays are emitted. So when he placed the electric field, so what will happen? See, the cathode rays are made up of negatively charged particle, that is electron. So obviously if an electric field is applied, it will bend towards the positive plate, because we know opposite charges attract each other. So when electric field was applied, anode and cathode, it bent towards the anode, showing that cathode rays are made up of negatively charged particles. Similarly, when magnetic field was applied, it bent towards the north. Again, it shows the charge, that the cathode rays are formed of negatively charged particle. There were few more properties also, like when they fall on some hard metals, those hard metals started emitted X-rays, and even it can heat up the, you can say, the metals. It has the heating effect also. These cathode rays, they do have penetrating effect also. They can penetrate thin foils of metal, but they are actually stopped by the thick metal foils. They can penetrate to thin metal foils, but cannot penetrate through thick metal foils. So these were the all properties which a cathode rays exhibit. Now, what is the mass, charge and the properties of the other cathode rays, the particle which we have discovered in the cathode rays, a constituent of cathode ray, that is electron. So what is the mass? The second consideration, we should know what is the mass of the particle. So mass of electron is 183.7 times less than the hydrogen atom, which was calculated to be 9.1 into 10 raised to power minus 31 kg. So this is the mass of that particle which was the constituent of cathode ray. Secondly, the charge, now we know the charge is negatively, definitely it is negative, as I have told you with this figure, that when the electric field was applied, it bent towards the anode, showing that it is formed of negative charge. Now the question being, what is the magnitude of the charge? So there were certain experiments which you will be doing in the higher class, R.A. Millikan oil drop experiment, which Millikan actually was successful in determining the magnitude of the charge, which was calculated to be negative 1.6 into 10 raised to power minus 19 coulomb. So this is the charge on the that the electron has. Similarly, get to know the charge to mass ratio also, that was 1.7 into 10 raised to power 8 coulomb per grams. So this is how J.J. Thomson made the discovery, and the other scientists which helped him in determining the mass, charge and charge to mass. And one more important thing, just keep in mind, whichever gas you take in the tube, whichever gas, because now it is the successful discovery which is made by the J.J. Thomson. So you must be curious to see that whether if you apply those conditions, then cathode rays are emitted or not. So just keep in mind, whichever gas you take in the tube. So the properties of the cathode rays, the mass, charge to mass ratio always remain same. It does not depend upon the gas which is taken. It does not depend upon the metal which is used in making electrodes. So that means the nature of cathode rays irrespective of the gas taken and the electrode which are made, the metal electrodes which are used. And the glow definitely depend upon the gas, but still the properties of electron remain as such.